Day everyone, especially to our instructor, Ma'am Hannah Panteleon, and to my fellow forestry classmates. Today, I will be discussing my assigned topic under the lesson given to our group, Distinguish Soil Formation, Development Process, and Landforms. So, what is soil? Soils are natural and consolidated materials on the surface of the earth. Soils have evolved through natural processes as a dynamic and a three-dimensional body. Soils have three phases: solid, liquid, and gas. The solid phase contains organic and inorganic materials intimately mixed together by natural processes. The liquid phase consists of water with dissolved salts, acids, bases, and ions. The gaseous phase consists of soil air, which renews from time to time from the atmosphere. Now, soil formation. Soil forming factors. Materials and conditions that determine the course of soil development and affects the characteristics of soil are called soil forming factors. Jenny 1941 identified 5 soil forming factors: climate, organism, relief or topography, parent material, and time, and proposed an equation to show relationships of a soil property with these soil forming factors. The soil forming equation may be written as where S equals any soil property, Cl equals climate, O equals organism, R equals relief or topography, P equals parent material, T equals time, and F equals function. So the first one, soil forming factors, is called climate as a soil forming factors. Conditions of rainfall, temperature, humidity, solar radiation, day length, etc. at a place over a long period is called climate. Climatic conditions at a place depends on geographic location, elevation, velocity, and direction of prevalent wind, position of land in relation to sea, ocean, and mountains, characteristics of oceanic current, etc. The two most important elements of climate that affect soil formation are rainfall and temperature. Rainfall and temperature influence the kind and degree of weathering, nature of weathering products retained or lost, production of biomass and decomposition of organic matter, geochemical processes operating in the parent materials, circulation of materials within the soil, etc. There are two types of climate as a soil forming factor. Number one is precipitation effects. Water acts as a reactant and a medium of translocation. As rainfall increases, rate of weathering, depth of weathering, diversity of weathering products, formation of clay, release of soluble substances, and organic matter production increase. However, leaching of materials in solution and suspension also increase when precipitation exceeds evapotranspiration. In very dry conditions, physical weathering is relatively intense and the resulting parent material is sandy. Due to scarcity of water, there is little chemical weathering and inadequate leaching. In moisture regions where there is some rainfall but the potential evaporation is higher than precipitation, there is some chemical weathering and formation of soluble salts, but due to insufficient water to leach them downward and by capillary rise of groundwater, a salt crust may develop on the surface soil. The second one is temperature effects. Temperature regulates the rate of chemical reactions. For every 10 degrees Celsius rise in temperature, the rate of chemical reaction is almost doubled. increased weathering, and clay formation occur when an average increase in soil temperature at optimum soil moisture level. Both organic matter production and decomposition increase when the increase in soil temperature. The organic matter content of soil is the balance between organic matter production and mineralization. Both production and mineralization of organic matter are low in boreal forest soils. They are usually rich in organic matter because the microbial decomposition rate is slower. 2. The second soil forming factor is organism. Organisms that influence soil formation include plants, natural vegetation or crops, microorganisms, algae, bacteria, actinomycetes, and fungi. Animals including vertebrates, burrowing animals like moles, and mesofauna, earthworms, ants, termites. These organisms live in and on the soil or exploit it. Among the changes they cause are addition and decomposition of organic matter, additions and losses of plant nutrients, geochemical cycling, soil mixing, and changes in soil structure and porosity. Plants extend roots to greater depths of soil and create channels which facilitate movement of water within the soil. Among the changes they cause are addition and decomposition of organic matter, addition and losses of plant nutrients, geochemical cycling, soil mixing, and changes in soil structure and porosity. Plants absorb nutrients from deeper zones of the soil and return them in later on the surface. Thus, plants redistribute materials within the soil. The amount and proportion of nutrients absorbed from the soil differs with plant species. Some plants absorb and return more bases than others. Litter from such vegetation tends to prevent soils against becoming more acidic. Human effects on soil formation. Human effects on soil formation are either direct through plowing, cropping, liming, manuring, or indirect through changing the natural soil forming factors, changing the vegetation by deforestation, changing the relief by leveling and terracing, changing the moisture regime through irrigation and drainage, changing the parent material through transport, dumping, or the exploitation of peat and rocks, and erosion and sedimentation. Corresponding soil changes vary greatly in kind, intensity, time, and spatial scale, and significance for soil and environmental quality. In land uses such as agriculture, surface horizons have usually been more altered than subsurface horizons, while engineering activities often change the entire sequence of soil horizon. Anthropogenic soils. Anthropogenic soils are soils that bear the signs of long-term human impacts in their characteristics. They are human-altered and human-transported soils. According to USDA and NRCS 2007, these soils are classified as having an anthropic or a Pleiadian epipedeme, and in other categories having the formative elements anthroptic, anthracic, anthropic humic, anthropomorphic, portic, pelagic, and plaghaplic in United States Department of Agriculture, USDA Soil Taxonomy. Number 3 soil forming factor is the parent material. Parent materials are the main raw materials from which soil is ultimately formed. So, many of the properties of parent materials may inherit to the resulting soils. Soil texture is mainly inherited from the parent materials. Coarse textured parent materials generally produce coarse textured soils. Mineralogical and chemical compositions of parent materials are also very important in soil formation. For example, acid parent material tends to produce acid soils. Lime-rich parent materials produce calcareous soils. Mineralogical composition and fertility of soil also depends on the mineralogical composition of the parent materials. However, the effects of parent materials are dominant on young and immature soils. Under warm and humid climate, the effects of parent materials largely disappear as the soil grows older. Actually, many different parent materials may produce similar soils depending on other soil forming factors, particularly climate. Types of parent materials. Organic soils develop from organic parent materials, formed by the deposition of residues of many generations of vegetation, usually under wetland conditions such as swamps and marshes. There are two types of organic deposition: peat, if the residues are sufficiently intact to permit the fibers to be identified, and muck, if most of the material has sufficiently decomposed so that little fiber remains. Characteristics of soils formed from different rocks. Volcanic ash, fine textured soils with plenty of easily weatherable minerals. They contain high organic matter and available nutrients. Granite, coarse textured soils with medium fertility. Most soils are friable and permeable but acidic and low in base status. Basalt, fine textured soils with sufficient easily weatherable minerals. In temperate regions where water is available, these soils are very productive. Sandstone, poorly fertile coarse textured soils. Limestone, fine textured soils with variable fertility. Number 4, topography as a soil forming factor. Topography refers to the configuration, surface feature of the land. Topography has a strong influence on soil development. Soils on the side of hills tend to be shallow. Surface material are continually removed by erosion. Soils on the tops of hills tends to be deep. Soils in the valleys are deeper and contain more horizons. Soil materials are continually deposited from upper slopes in foothills. Topography influences soil formation through its effects on drainage, infiltration, runoff, erosion, and exposure to sunlight and wind. It causes localized changes in moisture and temperatures. Soil on hilltops are drier than soils at the bottom of hill slopes. When rain falls on a hill slope, for example, water runs down from the top of the hill. Excess water collects at the bottom of the hill. The drier soils at the top are quite different from the wetter soils at the bottom, even if both soils form under the same overall conditions of climate, organisms, parent material, and time. To, uh, the fifth and last soil forming factor is time. The soil originates, grows, and matures with time. The time required to develop a soil varies from some centuries to some millions of years, depending on other soil forming factors. Generally, profile development and horizon differentiation are faster under warm, humid, and forested conditions because of higher weathering and leaching of bases, colloids, and other materials. On an average, it takes 200 to 400 years to form 1 centimeter soil in environments characterized by mild climate. In tropical areas, soil formation is faster. It takes 200 years. There is considerable confusion on how to estimate the age of a soil. Since parent material is the initial state of the soil system, the time of soil development is the difference from the time of parent material formation to the time of studying the soil. However, it is difficult to determine when parent material has completely formed and when pedogenesis has started. Weathering and pedogenesis occur simultaneously in nature, so the age of a soil is sometimes measured from the time the rock was first exposed to the surface or from the time the alluvial material was deposited. Soil is a non-renewable resource. Forming soil of a furrow lies 15 centimeters depth and accumulating enough materials to make the soil fertile needs about 3,000 years. Degradation of soil fertility may occur within some years. Soil has limited resilience capacity, but it takes thousands of years to recover if its fertility is lost. For these reasons, the soil is considered as a non-renewable resource. Once it has been destroyed, it is lost forever. So that ends my discussion to my assigned topic. Thank you for listening. And the next reporter will be my groupmate Honey Jane Qualbar. She will be discussing the continuation of soil forming processes.